This is part 1 of the final review for BST 611. We'll review the description of variables, both categorical and continuous, and we'll review the types of tests available for categorical and continuous variables and reporting of your results for both types of variable tests. No matter what types of data you have or what your statistical tests are, you need to summarize the data first. Data will come in mainly 2 types, categorical and continuous, and recall that JMP uses modeling type, nominal, ordinal, or continuous, to determine which analyses are appropriate. For categorical variables, where your responses are in groups, either nominal or ordinal, then report the frequencies and proportions. 95% confidence intervals may also be appropriate. If the variable is fixed by the experimental design, then the 95% confidence intervals are not appropriate. For example, you wouldn't put a 95% confidence interval about the gender, about male or female. Those are fixed variables and they do not change, and so an estimation of the proportion there is generally not appropriate. For continuous variables, consider the shape of the distribution. This is where we start our inspection of normality. Look at the histogram, use the normal quantile plot. Recall we like normality. Most of our statistics are robust to departures from normality. And if we have large samples, then the central limit theorem may hold, and we may not need to worry about the normality assumption. In smaller samples, we're looking for evidence of departures from normality. We can look at the underlying variable we're using, or we can assess the central limit theorem and the normal quantile plot. Otherwise, we can use non-parametric methods. When reporting continuous variables, if normality is justifiable, then report the n, the mean, the standard deviation, and likely 95% confidence intervals on your outcomes. Remember, the standard error is a summary statistic about the mean. The standard deviation is a summary statistic for your sample. You should report the standard deviation when you are describing your sample. If your data are clearly not normal and you end up running a non-parametric based test, then you should report the n, the median, and either the interquartile range or the range, which is the minimum and the maximum. When moving past descriptive statistics to make inference, you need to consider the response variable. Is it categorical or continuous? If it's categorical, you can look at the midterm review. The majority of the tests are covered in the midterm review. You will summarize categorical response by counts and proportions. Don't forget the n missing. We've looked at 3 tests for comparison of proportions: an observed proportion to a hypothesized or historical proportion, 2 observed proportions, and multiple observed proportions. In observed versus assumed, we first started with a z-statistic or a z-test. This is commonly not utilized and will generally be a chi-square or an exact binomial or a Fisher's exact test. Here we're looking for whether our observed p is equal to an assumed proportion. When we have 2 observed proportions, we want to know if p1 equals p2. For example, if the proportion of females is equal across 2 outcome groups. The simplest test statistic is a chi-square. If the sample size assumption does not hold, then it's the Fisher's exact test. For multiple proportions, again, we're asking whether the proportion of one group is consistent across the levels of the other variable. This is a chi-square test of equal proportions, also called a test of homogeneity or a test of independence. Again, if the sample size assumptions don't hold, it's the Fisher's exact test. All of the tests on proportions are generally accomplished with the chi-square test. Remember to look at the expected frequency counts. If more than 20% of cells have an expected count less than 5, then you'll need to do the Fisher's exact test. JMP reports the Fisher's exact test for a 2x2. You need to ask for it for anything larger than a 2x2, but JUMP will give you a warning in either case if you need to utilize an exact test. Again, always report the overall N, the N per group, any missing and where and potentially why if you know, and the percent in each group, and then 95% confidence intervals either for the groups or the difference in proportions may be appropriate. When we have a continuous response, a random variable, we started with a Z statistic, but again, that is rarely used, and the majority of time you'll use a T statistic for two means, either paired or independent, or the F statistic for any test. You could compare one mean to an assumed mean, two means either paired or independent, multiple means, and we could look at relationships between two continuous variables. For one mean, the question is it different from a hypothesized mean? If the answer is yes, that is my question, then look at the one sample mean notes. You'd use the t-test to compare to a specified value. For two paired means, that is, I have one sample of subjects and I have a pre-post test. We want to know if there's a difference. We must use the methods covered from two means from a paired measure. And in most cases, what we will do is actually create a difference score and compare that score to 0. And that is a paired t-test. For two independent means, so the same response variable is measured on two different groups, two different samples. If the groups are independent, then this is an independent t-test, though it's normally simply called a t-test. Other considerations could change this. If you have unequal variance, then that's the unequal variance t-test, or clearly non-normal data, and that will be the Wilcoxon test. In all of the examples, we're looking at a t statistic, either the paired t, the equal variance, or the unequal variance, or if normality is not warranted, then it's the Wilcoxon. For multiple groups, so you want to compare multiple means, you first have to determine with the F-test if there is a difference in means. If that answer is no, you are done. Report that there is no detectable difference between means and summarize your data. If the answer is yes, that we find, or the F-test finds an overall group difference, then you can use the Tukey's HSD multiple comparisons procedure to determine where the difference lies. You could also use the Wilcoxon test and the Steele-Dwas comparison. If I have two continuous random variables, then I'll be looking at correlation. If normality is warranted, that's Pearson's R. If you'd like a rank order correlation, that is Spearman's rho. Recall that both of these assume a linear relationship between your two continuous variables in the ranks or in the raw form of the variable. When reporting, again, it's the N missing, and N per group. Report the mean or medians per group as determined by the distribution of your variable. Remember, means imply you have normality. It also implies that it is a symmetric distribution. Report the standard deviation, or if you've reported the medians, then use the minimum or maximum or the interquartile range. Report the differences between the means if there is a difference, and only if there is a difference. And to determine where, again, use Tukey's HSD or Steele-Dwas according to the normality assumptions. Report correlation if that is your question. For all variables and for all comparisons, describe your overall data. Describing the sample will help determine what population inferences you can make from your results. You need to put the question in words. Report the results of your statistical tests, but interpret the results of those tests in terms of your data and the question at hand. Remember, the answer isn't the groups are different. The answer is the groups are different, and here's where the groups are different. Here's the direction of the difference, and here's what the values are for each group. Use tables and figures to help explain your results, and always, above everything else, put your data in context. Do not leave interpretation up to your reader. Make it clear to your reader what you tested, what you found, and what that means.